Right, let's take a look at how to name branched hydrocarbons, and by the end of this session you should be able to name and draw simple branched alkanes and alkenes that go up to 8 carbon, that have got 8 carbon atoms in their chain, and with alkenes we're going to be only focusing on 1 double bond per alkene. So when we're talking of branches, sometimes some bookmakers might call them substituted hydrocarbons, because you'd have removed a hydrogen from the chain and probably put as another side chain where there was a hydrogen. Okay, so when we're looking at hydrocarbons generally, we have a situation like this here where we've got side chains. Let's say I'm starting from this carbon here, looking at this structure going that way, right, where I have this CH3 group of atoms. It could have been hydrogen there. So what we have done is we have substituted the CH3, the hydrogen, which is with the CH3, which makes this one a branch. Okay, just looking at what we know already. I always say learning is linking what you know to what you don't know. We all know a tree, and a tree has got what we call a stem, right? Where this stem ends can be debatable. Someone might say, okay, this is the stem going that way. Another person might turn around and say the stem ends here. Another one might say that, and another one might say that. Another person might say whatever they want to say about, which one is the stem, because we've got so many. At the start here it's pretty distinct. We can see that this is the stem, but once we get here, we've got so many branches coming out of this main stem. So how do we determine which one is the longest? Which one is the stem? Not which one is the longest. Which one is the stem? For us to avoid a situation where we're going to have this ambiguity, where pretty much everyone is coming up with an opinion of what they think the main stem is for this tree, if we establish a rule that, okay, the stem is going to be from the base of the tree and to the tip where we have got the longest, like in terms of distance. So we're looking at how long this is from here up to there, and how long this is from here up to there. The one that is the longest of all these options that we have will be our stem. Basically, the thinking would be the longer it is, the more stable and the stronger it is to sustain branches, because you can't have branches sitting on a stem that's weak. That tree will fall apart. So we don't want that to happen. Same with alkanes and alkenes. What we do is we look at a structure like this one. I've just started you off with a complex one straight away, so that you understand what I mean by branches. What we might find out, especially getting back to this here, we might find out, we could have been assuming that the stem was this one, which is straight, almost straight going up, but it's not always the case. You might find when you measure this might be the longest, and that might be the longest, or that might be the longest. So it doesn't necessarily mean that your longest trajectory or route to the tip of the tree is always going to be the straight one. It doesn't work like that all the time. Same with hydrocarbons. It doesn't mean that when I've got a straight, my longest chain is always going to be a straight horizontal one or vertical one. Let's take a look at this here. It involves a bit of testing and checking which one you think is the longest chain. Or sometimes just by looking, you'll be able to say, well, this looks like the longest chain, but always double check by counting. For example, if I start from this carbon and I count horizontally straight like that, I've got 1, 2, 3, 4, 5, 6 carbons here in this chain, right? And if I look at maybe counting in this direction, 1, 2, 3, 4, 5, 6, I've got 6 as well. And I've got 1, 2, 3, 4, 5, 6, 7, 7. So which means this one is no longer the longest chain. It has been beaten by that one. And you know, straight away I would go to what I know the answer is so that we don't spend time. This was just to show you that you need to physically count sometimes to make sure you're not getting it wrong. If I count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this will result as my longest chain. You can double check that. If I got it wrong, you can just send me a message below and we will have to fix that. But I know this one is the longest chain. So this longest chain is going to be my principal chain. This will form the base name for this organic compound, and everything else I have around this is what we call the branches. So I have to group all these carbon and hydrogen atoms, and they will be the branches of this principal chain. They are branching off the principal chain. So the objective of this lesson is for you to be able to name those this organic compound or the hydrocarbon, and also include the names of the branches. Those side chains, there's a special way of naming them which we're going to look at later, actually straight away. Now just for you to have something to write down in your book for revision purposes, hydrocarbons can have branches which are also known as substituent groups, or they can be called side chains, or they can be called branches. Depending on the book text you are reading, it's one and the same thing. So side chains can be what we call an alkyl group. What is an alkyl group? It's an alkane minus a hydrogen, right? And we name them almost the same way we name alkanes, using, counting the number of carbons to get the prefix, but the suffix for alkyl groups is going to be YL, right? So I find my prefix from the number of carbon atoms, and then instead of using ANE as my suffix, I'll use YL as my suffix. Right, so you need to write this down as well. These are named using a normal prefix plus suffix. By normal prefix, I mean using the same rules we've been using before of saying 1 carbon is meth, 2 carbon atoms is eth or eth, 3 carbon atoms is prop, and on like that. We have already put together a video with that. So it means an alkyl group which has got 1 carbon atom will be called a methyl group. An alkyl group which has got 2 carbon atoms is called a methyl group, and an alkyl group that has got 3 carbon atoms will have called a propyl or propyl group, depending on how you want to pronounce that. Now, I've got a table here just to show you what I mean by that. So we said an alkyl group is a normal alkane where we have just removed a hydrogen. So if I take away a hydrogen from methane here, which is CH4, I end up with CH3. This CH3 is an alkyl group. So because it has got 1 carbon, the prefix becomes meth and the suffix becomes YL. So we call this one a methyl group. To get back here to where we were, right? You can see that on this one here, if we consider this to be our longest chain, the one we identified earlier, CH3 and CH3 and CH3 are side chains, and we name these as methyls, right? So we've got 1, 2, 3 methyl groups. And if we move on again, looking at carrying on with our explanations here, if I take ethane and take away 1 hydrogen from that, I end up with C2H5. Right, and the name for that, the prefix is eth for 2 carbon atoms, and we put a suffix of YL, so it becomes an ethyl group. The next one will be propane, which is C3H8, And looking at this one here, if I take one hydrogen from the from those 8 that I have on there, I remain with C3H7, which means the name for this one would be prop for 3 carbon atoms, and the suffix is YL, which gives me propyl group. I can carry on with C4H10, which is butane, and I end up with C4H9, which is a butyl group, because I've got 4 carbons. Usually the common ones are these ones here that we have here. Most of the time you find once you start to have a side chain that go in the order of 5 carbon atoms, 6 carbon atoms, highly likely you might have made a mistake on identifying your longest chain of the hydrocarbon. Right. Still looking at branches, we've got other common side chains, which are your halogens. Yeah, halogens can be part of the chain. So I can have a hydrocarbon like this one here, where I've got hydrogen, hydrogen here, hydrogen there, hydrogen, hydrogen. I can have chlorine and hydrogen, 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 and another hydrogen here. Hydrogen atoms are not considered as to be side chains, but anything else that is not a hydrogen, which is coming from the longest chain, because this is our longest chain of carbon atoms, is considered a side chain or a branch. So if I've got chlorine like that, there it becomes a side chain. How do we name halogens when they form side chains in an organic molecule or in a hydrocarbon? They become named as chloro, fluoro, bromo, and iodo. Right, these are the common ones we're going to be coming across as we work through this syllabus. There could be any other elements, like, you know, we can have NO2, which becomes nitro. Okay, this is nitro. It's named as nitro. It's another one I need to add on there. But in most cases, once I start having something like this here, let's say I've got an OH group here, which has substituted a hydrogen, or which has taken the place of hydrogen in this chain. This one here is not considered a branch or a side chain. Why? Because it's a functional group. So there's a limit as to what we can consider side chains, but you will learn more about this when you get to year 12. At this stage, the side chains you're going to come across are these ones here, and your alkyl groups and the nitro. So those are the only ones we're going to come across. Right, so I'm going to pause this. I'm actually stop this video. It's 12 minutes. I wanted to try and keep them as short as possible, and we'll come back and look at how can we name this hydrocarbon here. I shall see you when you look at the next video.